Greetings and welcome to our discussion on the properties of logarithms. Now guys, I gotta be honest with you. This, in my opinion, is one of the coolest topics that we get to talk about in this section, because how often is it that you can talk about a product becoming a sum, and yet with logarithms that's exactly what happens. If you look here, log base a of u times w becomes log base a of u plus log base a of w. A quotient becomes a difference. Log base a of the quotient u over w becomes log base a of u minus log base a of w. And log base a of u to the c equals c times log base a of u. And so when we get ready to prove these results, we're going to do a couple things. We're going to let r equal log base a of u, which means that a to the r power is u. And log base a of w equals s, which means a to the s power equals w. And so when we multiply u and w together, u we said was a to the r, w is a to the s. We know that when we multiply like bases, we add the exponents, which is where r plus s comes from. You will remember that I've always said, if a cat's in a tree, call the fire department. If a variable's in an exponent and you need it down, call a logarithm. So we take the log of both sides, log base a of both sides, and log base a of u w equals r plus s. Remember that r equals log base a of u, s equals log base a of w, and there we go. I'm not going to take the time to walk you through proofs 2 and 3. Please kind of read through them. If you have questions about how they work out, why, let me know, and we'll certainly talk about them in class. Be more than happy to do that. The rules for common logs work the same as the rules for natural logs. One thing that we need to pay careful attention to, I should probably get the red marker out here and circle this. This is a big deal. Guys, I can spot this a mile away. The log of a sum is not the sum of the logs. The log of a sum is not the sum of the logs, nor is the log of a difference the difference of the logs. Alright, so we need to keep that in mind as we move forward here. What we're going to try to do is we are going to express this in the terms of logarithms of x, y, z, or w. Now, what we're going to notice here is that we've got log base a of the top, y to the fifth, w squared, minus log base a of x to the fourth, z cubed. So what I've got, folks, is the log of a quotient. And that quotient now is being split up into the difference of the two logs. Now you'll notice that I've got the log of a product here, and we know that when we multiply arguments, we add logs. So this becomes log base a of y to the 5 plus log base a of w squared minus bracket. Because you notice once again we've got the log of a product. So this becomes log base a of x to the 4 plus log base z cubed. Alright, and so now the other result here that I kind of skimmed over a minute ago is that if we've got log base u to the power of c, this c gets to come out front and become a coefficient. Please remember that coefficient is the fancy word that means number in front of the variable, or in this case, the number in front of our logarithm. And so what I'm going to do is I'm going to take the exponent out front, 5 times log base a of y, plus 2 times log base a of w. Now I'm going to distribute the negative through, so minus 4 log base a of x minus 3 log base a of z. Alright, questions there? Doing okay? If not, make a note of what's confusing you. We'll be happy to look at them. Now you'll notice in this next example we've got the natural log of x times the cube root of all of this. So this becomes the natural log of x times y to the fourth over z to the fifth raised to the 1/3 power. And another way to think about this is the natural log of x times y to the 4/3, because when you raise an exponent to a power you multiply, and then this is z to the 5/3. Now we've got the log of this product divided by this guy, so this becomes the log of x y to the 4/3 minus the log of z to the 5/3. Okay, log of a quotient is the difference of the logs. Now notice here that I've got a product. So this is the natural log of x plus the natural log of y to the 4/3 minus the natural log of z to the 5/3. And so now my exponents are going to go down. Natural log of x plus 4/3 natural log of y, so that exponent goes out front and becomes a coefficient, minus 5/2 times the natural log of z. A lot there. You may want to rewind it and play that through again. And for class discussion, there's a problem to work, and then for homework, a few other problems to work. Let's go the other way now. We've got the sum and difference of logs, and we're going to express them as a common logarithm. Now in order to do that, we've got to get all these coefficients rewritten as exponents. So this becomes log base a of x to the 5 minus log base a of 3x minus 4 to the 1/2 minus log base a of 5x plus 1 to the 3rd. Now you say, well, I can't divide by two things. What am I going to do here? Well, here's a suggestion. This is log base a of x to the 5th minus bracket log base a of 3x minus 4 to the 1/2 plus log base a of 5x plus 1 cubed. So I factored a negative out front. Log of a sum, the sum of the logs is the log of a product. So this becomes log base a of x to the 5th minus, I don't really need the bracket here, but I'll put it in, log base a of 3x minus 4 to the 1/2 times 5x plus 1 to the 3rd. And so now we get log base a of x to the 5th divided by 3x minus 4 to the 1/2 times 5x plus 1 to the 3rd. And so we have just expressed that as the sum, as a single logarithm. So the sum of the logs there we've just expressed as a single logarithm. Moving on here, looking at our next example, we're going to do the same thing again. We're going to try to collapse all of these into one log. So let's see, we've got the natural log of x squared, pushing the 2 up there, and minus the natural log of 1 over y to the 4th minus the natural log of xy cubed. Alright, so let's keep in mind what's going on here. This becomes the natural log of x squared minus the natural log of, guys, I'm going to rewrite this as y to the negative 4. Okay, 1 over y to the 4th is the same as y to the negative 4. And just kind of hold with me. We'll take care of that negative exponent as we go. And this is going to be minus the natural log of x cubed y cubed. Alright. Now again, you say, well, we've got two minuses here. Never fear. We can factor a negative out. This becomes the natural log of y to the negative 4 plus the natural log of x cubed y cubed. Now you might notice that we've got the sum of the logs. The sum of the logs, folks, becomes the log of this product, y to the negative 4, x cubed, y to the 3. So now we've got the difference of two logs. The difference of two logs, you will recall, becomes the log of the quotient. So this becomes the natural log of x squared over y to the negative 4, x cubed, y cubed. And some of you are probably thinking it now, why does he have two y's here still multiplied together? Outstanding question, just haven't combined them yet. Let's go ahead and combine them, that way we're not thinking about it. So this becomes the natural log of x squared over x cubed, y to the negative 1. And we know the x squared over x cubed will simplify. That'll put an x on bottom. We'll move a y on top. And there we go. And so we've given you a problem to work for class discussion and some problems to work for homework. Let's use these properties now in solving log equations. So we've got log base 4 of 3x plus 2. And this is going to equal log base 4 of 7 times 3. And so we learned back in one of our prior lessons that if our bases are the same, our arguments have to be the same. Subtracting 2 from both sides, 3x equals 19. And x equals 19 over 3. And of course we need to check that, but when we do, we can put that back into our original. When we do, we don't have the log of a negative number, so we're good, ready to go. Now we'll notice here on the next example we've got the log, or the difference of two logs. So we can rewrite this as the common log of x over 2 divided by x equals, and I'm going to go ahead and bump this, that wasn't what I wanted to bump. And there we go. I'm going to go ahead and bump this coefficient up here to make it an exponent. And so this is going to become the log of 4 squared. Log of 4 squared. And so what we've got here is x plus 2 over x equal 4 squared, which is 16. Alright, and so x plus 2 equals 16x, 2 equals 15x, and so x equals 2 over 15. And so I apologize, that little guy keeps popping in there. Certainly if you have questions, make note of them, and we will happily discuss them in class. As we move ahead here, we will continue to apply some of the rules that we've already learned in this unit. Notice we've got the sum of two logs, which means this is the log of x minus 2 times x minus 4, and this equals 2. Now you say, this is no good. We don't have a log on the right side. What will we do? Well, remember, folks, that we've got a base 10 here. We didn't have it written, but we've got it. So x minus 2 times x minus 4 equals 10 squared. Alright, so over here we've got x squared minus 6x plus 8 equals 100. Good old-fashioned quadratic equation here, x squared minus 6x minus 92 equals 0. And I need to apologize here, folks. We did have a base on the log, didn't we? We did have a base on the log, and that base was 3. And so my apologies here. This is log base 3 of this argument equal to, so 3 squared equals all of this. That equals 9, and so now we get x squared minus 6x minus 1 equals 0. And so that unfortunately will not factor. We'll need to use the quadratic formula here. X equals the opposite of negative 6, plus or minus the square root of negative 6 squared minus 4 times 1 times negative 1 all over 2 times 1. So we get 6 plus or minus 36 plus 4 all over 2. 6 plus or minus the square root of 40 all over 2. We'll break that down. 6 plus or minus square root of 4 times the square root of 10 all over 2. So x equals 6 divided by 2 is 3. This, folks, is a 2. 2 divided by 2 is 1. Plus or minus root 10. We check out our problem here. Will either one of these cause one of my arguments to become negative? Well, clearly 3 minus root 10 is going to be negative, and it won't work in either one. So only x equal 3 plus root 10 is the solution. Now, if we look at our next example here, once again, one of our terms does not have a log associated with it. That's okay. This becomes the natural log of x minus the natural log of x plus 1, and this equals 1. We know that the difference of two logs becomes the quotient, the log of the quotient. So the log of x over x plus 1 equals 1. We know here that we've got a base e, so x over x plus 1 equals e. We're going to clear the fraction. X equals e times x plus 1. So x equals ex plus e. I need to solve for x, so I'll get all the terms with an x in them on one side. X minus ex equals e. We'll factor out an x. 1 minus e times x equals e. And so x equals e over 1 minus e. Now again, we need to worry about whether or not this will work. And e over 1 minus e is approximately negative 1.58, which is less than 0, so there is no solution to this particular equation. Always got to be on the lookout, folks, that we don't have an extraneous solution there. And we have one here in this particular example. So we've given you some problems to work for the class discussion, and we've given you some to work for homework. Let's proceed on here and look at some application problems. It says when the volume control on a stereo system is increased, the voltage under a loudspeaker changes from V1 to V2, and the decibel increase in gain is given by this function. They want us to find the decibel increase if the voltage changes from 2 to 4.5 volts. Well, so our decibel increase is equal to 20 times the log of 4.5 over 2. And this works out to be approximately 7. So that's the decibel increase. We gain about 7 decibels there. They want us to refer to the exercise we just worked. It says what voltage ratio K is needed for a 20 decibel gain and then for a 40 decibel gain. Well, let's see what we need here. We want a 20 decibel gain. Alright, so we need 20 to equal 20 log of K, which means 20 over 20 equal the log of K. 1 equals the log of K. And so remember, guys, there's a 10 that's hidden down here, so this is 10 to the 1, or 10 equals K. And then for a This is 56 here. Then for a 40 decibel increase, we're going from 20 up to 40. Log of k. 40 over 20 equals the log of k. 2 equals the log of k. So 10 squared equals 100. And that is our k value. So that's the decibel gain we would need there to be able to make that happen. Finally here, this last example, the energy E of x of an electron after passing through material thickness x is given by the equation E of x equals E sub naught e to the negative x over x sub naught, where E sub naught is the initial energy and x sub naught is the radiation wavelength. They want us to solve basically here for E sub naught, the energy of an electron after it passes through a material of thickness x sub naught. So what we have here for part A is E of x sub naught is going to equal E sub naught e to the negative x sub naught over x sub naught. Alright, well, we see this becomes E sub naught times e to the negative 1. And remember here, we're solving for E of x sub naught, which is what we're looking for. Let's get that negative exponent out of here. E sub naught divided by E is big E of x sub naught. Alright, so we get a constant there, constant function. And then part B wants us to express in terms of x sub naught the thickness of material at which the electron loses 99% of its initial energy. So what we've got is all of the initial energy. We're going to lose 99% of that initial energy, and so that gets me 1% of the initial energy left, and we know that that is equal to E sub naught e to the negative x over x sub naught. Alright, and so if we divide both sides by E sub naught, 0.01 equals e to the negative x over x sub naught. We need to take the natural log of both sides here. And remember, we're about to show what fraction of the original we had. And so we're going to divide both sides by negative x sub naught. Actually, I'm going to multiply both sides by a negative. Negative natural log of 0.01 equals x over x sub naught, and then x equals negative x sub naught ln 0.01. And there we go. You know, we could move this negative up here, and we could change that, but we're good with what we've got right here. That's what they're asking for. So certainly if you have questions on any of these, make note of them, bring them with you to class. We'll be more than happy to talk about whatever we need to.